So I found a wine data set from Wine Enthusiast magazine, and they took a large data set of wine reviews or descriptions and provided information for those. So I wanted to do something with natural language processing, and that had its advantages and disadvantages in this data set. So the wine reviews were all one sentence in length. That made them pretty uniform. That was easy to pre-process. The thing that stood out to me about this data set was that these wines were then scored on a scale of 0 to 100, supposedly. But if you look at the data, you can right away see that all the scores land between 80 and 100. So to me, that was like, oh, they're all good, but that's an exaggeration. That has no account for personal taste, terroir, the fact that these reviews are subjective, or that guessing how magazines work, I'm guessing these wine labels paid to have that spot in the magazine, so therefore they're sponsored. So I thought that was all kind of an interesting way to look at opinion and sentiment. And I'll skim over the process of pre-processing the data, but essentially I decided that either the scores were good or they were bad. So I made it bivariate for simplicity. And there was other information that would help in an ensemble learning method, but I thought, to be fair, it would be appropriate to test the text in either a word-to-vec ensemble method or a neural network, and we compared those two models together at the end, and I'll get to that. But another way to explain, if you're not totally familiar with natural language processing, another way to explain it is kind of like categorizing words, taking the meaning of a word and giving it a plot in space. Now these real vectors have more than three dimensions, but I condensed them down to just 3 dimensions to make them easier to view. And so what we have here are two of the reviewers' word choices in a 3D space. Now you can see there's a lot of overlap. There's also some outliers. And in this way, you can find something that I didn't mean to find, which was flavor notes. And I thought this was kind of interesting. You can find the words that are quote unquote near coffee, and you get other flavors that sound like they might taste like coffee. Same thing with words that you might not even think were a flavor. At least I didn't think brimstone was a flavor. So taking that same idea, you could also say, where are good, and see the words that are associated with good, and kind of run a model that's going to find good words and categorize them as a 1, as a good wine, and bad words and categorize them as a 0, a bad wine. So that's the thinking I had going into this. And by the time all the models were ran, I think I got something that looks good. So this first graphic that we're looking at is actually area under curve, rock area under curve visualization of the ensemble method. Now this is kind of like saying that ensemble learner, which I used, which was a random forest method, was able to do kind of like an accuracy of 69%. That's a little bit better than baseline. Baseline would be guess, is it a good or a bad? You have about a 50% chance, given that there's 2 outcomes of guessing 50%. So a little better, not much. We ran the neural network, and what it kind of looks like, what we're looking at here is each epoch. You run it for a set amount of times, cycles, and each cycle it gets a little bit better at reading the data that it is given. Now the dots are the training data. This is what it was able to see outcomes for and predict and adjust, and the validation accuracy. You can see actually goes down here because we overtrained, but the validation accuracy would be samples that the model hasn't had time to work with yet, and so it's testing its predictions against them, I think is kind of a way to explain that. Another way to show it is just to show confusion matrix, which to me is funny because they were very confusing to me the first time I saw them, but they actually make a lot of sense. So remember I said either bad is a 0 and a good is a 1. So if you look at this, it's just a little box grid where you can say, okay, I predicted it to be 0, and the true label was 0, and the number in there represents each sample that was a 0 and was predicted to be 0, and so on and so forth. Was a 1 predicted to be 1. You can see also was a dark blue color, and that's good. In this graphic, we're trying it to be, we want the false, was a 0, predicted it to be a 1, we want that to be white, and same for was a 1, predicted it to be a 0. So this looks pretty good. I thought it was fun working with this data set. I think there's other directions that I could take it given the time. I think it's really cool to think that you could generate data based on the reviews, giving each wine a new name. I just think that's kind of fun, and I think it's kind of useful for winemakers too to have that suggestion whether they want it or not when naming their wines. I think it's kind of neat that you can use computers to kind of help with creative tasks at this point. I also like the idea of building something that goes live, which can take those flavor notes that we stumbled across and pair, kind of like a recommendation system where you pair flavor notes that are adjacent and suggest wines that make sense for somebody, knowing that they like chamomile or rosé or something like that. That's all I have. A few links for you, and any questions?
Yeah.
Sure.
So you took the data set, you made it into a binary classifier. What was a good score and what was a bad score?
Yeah, so like I said, it was they range from 80 to 100, and if I were to show you the distribution, it would look pretty normal. So I just split it right down the middle. 90 and up was good. 89 and below was bad.
Okay. Could you go to the vectorized data set, the graph? I think it was like the second or third slide.
Yes.
Yeah, who is Boone and O'Keefe?
Oh, sorry if I didn't explain that. Those are just two of the tasters. So there was a neat thing. The data set labeled each of the tasters. And in here, I'm just looking to see how their word choice was different. If I had more time, I'd like to kind of find, like, subset the data and find words that were unique to each taster, just kind of for fun. But I didn't get there yet.
Yeah, this is kind of interesting. Maybe like it kind of looks like from this slice of it, it looks like Boone had more of a spread of words that he used than O'Keefe.
Yeah, and depending on what those words are, I doubt it's working this way, but if those were like good words, you could then assume that Boone is a more generous reviewer.
Mm-hmm. I guess, yeah, that's kind of cool. Could you go to the next slide? Yeah, I thought this slide was super interesting.
Yeah.
I'm not a big coffee person. What is brimstone?
Oh, brimstone's not for eating. Brimstone's like fire and brimstone, sulfur. It's like a volcano thing. It's a rock, okay, as far as I know. Like, that's all I know.
Yeah.
So, like, brimstone and granite kind of make sense, but the rest of these don't make a lot of sense in, like, common vernacular.
Okay. Then another question I had, with the random forest, you got an AUC of 0.69, right?
Mm-hmm.
What do you get for, are all these graphs, are they for the random forest, or?
No, sorry, this first one's random forest, and now this is the neural network.
And you got an
Same
AUC
here.
of 0.69 as well?
I didn't actually run that on the neural network.
Okay.
I have an outcome report for the the random forest, but this just I kind of just put this in there to have a visual.
I gotcha. Which model do you think performed better, the random forest or the neural network?
I think the neural network, but this is the last thing I worked on, so I've been kind of trying to prove it, and I had a test set as well, which resulted in this confusion matrix.
Okay.
So this is after validating and then tested it on this.
Okay.
For a lot of the time working on the project, they were pretty similar though. So I think it's right, but
Okay.
I'm not far enough from the project yet to really, you know what I mean? Like I'm still kind of in it.
Did the random forest, did it use the pre-trained word embedding as well, or?
Yeah, yes it did.
Okay, cool. Yeah, that's all the questions.